So after the sulfuric acid poisoned much of the fresh water and the vegetation and such, much of the ejected dust and smaller rock fragments that were drawn up all the way on the atmosphere circled the Earth's atmosphere for a long time, and this contributed to global cooling, right? So if you have smaller fragments, just like the ashes from volcanic eruptions, they're going to radiate the solar radiation back to the space, and they're not going to let it infiltrate the Earth. So they're going to cause global cooling and winter-like conditions, which did not help those species that had somehow survived the blast, the fires, and the acid rain effects. So, because part of the impact also occurred in the ocean, so you can look at I think the book has a little bit of a better image. You can see that about half of it occurred in the ocean. There were plenty of tsunami waves that also occurred, and they hit all of the continents pretty much. Especially North America, which was the closest one. These tsunami waves were 300 meters in size. So if you know, most tsunami waves are typically on the order of maybe tens of meters. Hundreds of meters are not of this world, if you would. They're not commonly seen. So following the cooling effect, and once those particles actually settled, it's likely that there was a warming effect from the CO2 that was released by the pulverization of limestone rocks. So again, as the impact happened, much of the rock was completely pulverized and it was sent up into the atmosphere. So as I had said before, some of it was gypsum, so it contained sulfur, but some of it was also limestone rock, which contains carbon and oxygen as part of the elements that make it up. And so much of the carbon that was within that rock became carbon dioxide, and it was released into the atmosphere with the pulverization of the rock itself as well. So clearly, we can see that the ultimate effect from such an event resulted in a mass extinction. So they saw all sorts of things. They saw the impact, the fires, the sulfuric rain, the lack of heat, and then more heat because of the greenhouse gases that were released. All of it. They saw all of it within a very short period of time. And after all of this, large number of ferns actually were able to restore the plant cover on the burned landscape. And as we saw in the number of genera curves, there was a diversification of other species. So I can show you that real fast. So here, after the massive extinction, there was a relatively rapid diversification of the species that were remaining in the planet itself. So it is thought that if such an event were to occur today, it would probably mean the end of humans. That's pretty much a known thing. And much of today's diversity would probably go extinct as well, which would lead to mass extinction as well, just like the one that they saw 65 million years ago. So a sequence of events is depicted here in the images, and I pinpointed some of them, but it's kind of hard to see them. So page 575 of your book has them much larger and easier to see, so you can follow along what I just said. The sixth mass extinction occurred at the end of the Eocene epoch. So you're seeing it right here, and it doesn't seem as big from what is shown here. And that happened 34 million years ago. So although an impact is actually linked to this extinction, most scientists attribute the extinction overall to a change in global climate that was brought along by plate tectonics. So the movement of the plates at this time allowed for a cold ocean current to develop near the Antarctica, which is still going on today. And it caused, in part, the Antarctic ice sheet, actually. So the Antarctic ice sheet, as you know, is still present until this day. So it's been many millions of years, 30 plus, that the Antarctic ice sheet has been around, and it is believed that it is around partly because of the cold ocean current that developed near Antarctica and the southern pole. So overall, this change in the plate movement caused the global cooling and also the drying of our planet, which was the cause of this particular mass extinction in the late Eocene. A final extinction, not as big as the other 5 or 6, depending on how you look at it, happened 12,800 years ago. So this extinction happened as a cause of global warming overall, but it's a complicated event as well. So during the Pleistocene epoch, which is the one before the current one is the Holocene epoch, just so you're aware. So during that Pleistocene epoch, the world, especially the northern hemisphere, had seen a series of glaciations and also interglacial periods that ended about 12,000 or 13,000 years ago. So this resulted in the extinction of many mammals, reptiles, amphibians, birds, fish, and plants, and it continues up until today. So the initial cause of this event was first thought to be some combination of overhunting by Stone Age man and also of climate change. However, new evidence indicates that it may have been initiated by airbursts of a comet. In many ways, this extinction actually continues today, and this is largely due to human activities. So those activities include the loss of habitat from land use changes, widespread deforestation that we have caused, the application of pesticides and other chemicals, and also by human-induced global warming. So here I'd like to revisit the airbursts of the comet that we attribute was the beginning of the last extinction that I was talking about, the one that close to 13,000 years ago. About 12,800 years ago, North America, you can imagine, was a very different landscape. So it was covered with grasses and low shrubs mostly, kind of like a tundra type of thing. And it had clusters of coniferous trees. It also had large mammals, like mammoths as you're seeing here. It had dire wolves. It had large lumbering ground sloths. All of those beasts that you have probably heard about and seen in the movie Ice Age, for example. So along with those things, there were also the Clovis people, which are Stone Age people of the time. And these Clovis people were hunters of these said large mammals. To the north of this, there was a huge ice sheet called the Laurentide Ice Sheet, and it was about 100 meters high at its edges, so even much, much greater, closer to the middle areas. A few years later, however, this panoramic, if you would think of it, was much, much different. There no longer were any mammals nor people, and the ice sheet had advanced a very considerable distance, meaning it was greater. This was a glacial interval that we called the Younger Dryas interval, and a geologic time of even colder conditions that lasted about 1,000 and 1,300 years. 1,300 years, so 1,300 years total. And this was named after the tundra fossil pollen called Dryas plant. So that is why we call this area of even colder climate, this glacial area, glacial interval, the Younger Dryas boundary or formation or time. Okay? So the question as to why this sudden change in climate for the colder has really puzzled, or by now it's a little bit more understood, but it had puzzled scientists for a couple of centuries. They couldn't understand why this had happened. They had all the evidence, but they couldn't understand why. There was no clear evidence as to why that had happened. So in the 18th century, it was still thought that those huge mammals may still be present, which is kind of funny to think about. Fossil remains of them had been found, and it was thought that we simply had yet to encounter them in lands that had not been explored yet. So we had found some, for example, in Virginia and in the East Coast mostly, and so even presidents were suggesting that there could be these gigantic mammals, huge mammals, in the western lands where we hadn't yet explored. So it was near the 19th century that it was revealed that this megafauna, as you might think of it, and that the Clovis people had indeed gone extinct. There have been now 3 hypotheses in place. One, that the mammals were overkilled by humans. The second, that there was an abrupt cooling, and the third, that there was an extraterrestrial impact. So the first hypothesis is unlikely, given the amount of people that there were at the time, so it was probably not overhunting by the people. And it's also unlikely based on the amount of large animals, because there were a lot more animals than there were people to eat them. So also not accounting for those species that humans did not hunt, but that still went extinct. So some species, for example, of plants still went extinct despite the fact that that hypothesis said that they had gone extinct due to overhunting. So that could not have been the case. There was certainly abrupt cooling, so the second hypothesis could be true, but the abrupt cooling only happened at higher latitudes, so at really high northern and southern hemisphere. And the cause for this cooling, though, is still being debated. However, the extinction of the species was so abrupt and widely distributed that scientists believe that it could not be solely attributed to the cooling. And again, because we know the cooling only happened in higher latitudes. So, although the second hypothesis has some weight behind it, it could not have caused the whole extinction. At many Clovis sites, however, so Clovis, remember, were the people at the time, archaeologists have identified that what is referred to as a black mat. So that black mat is a dark clay-rich layer that marks the boundary of the Younger Dryas time at about 12,800 years to the boundary that follows it. So this black mat, again, is a dark clay-rich layer, and it appears at many of the sites where the Clovis people lived, or so archaeologists say. Remains of the megafauna and the Clovis culture appear in rocks that are below this clay-rich layer, but they don't appear in any remains, the remains don't appear in any rock structures or layers that fall above it. So, what is up with this layer? Is it any sign? So, another geologic mystery about this time is that the Younger Dryas boundary is the cooling episode that brought the Pleistocene epoch to a close. Many events that occurred at the Younger Dryas boundary suggest that the Laurentide ice sheet, as we had talked about it, remember Laurentide is in the North American continent, and the Fennoscandian, which is the ice sheet in the European continent, and also the Greenland ice sheets that once covered much of the northern hemisphere, were especially unstable. So even though it was cold, they were unstable. And some evidence for them to have been unstable are that meltwater drainage from Lake Agassiz, and Lake Agassiz used to be in what is now southeastern Canada, kind of, near Manitoba and Ontario and whatnot. So the meltwater drainage from that lake that used to be previously going towards the Mississippi, it now shifted, and the outlet now was towards the St. Lawrence River, so towards Hudson Bay, and also towards the Arctic Ocean through the Mackenzie River. So what was going on? Another evidence for the ice sheets to be unstable is that the margin of the ice sheet began to destabilize, and it began to melt rapidly with significant freshwater discharge into the surrounding oceans. And they can tell this based on the amount of sediments that were deposited at that time.